Welcome to AI Art Wizard. Let's talk about logical thinking, also known as reasoning. So, today we are tackling a claim you've probably heard 1,000 times. LLMs are just autocomplete. And we are going to do two things. One, explain why that claim sounds true. Two, demonstrate why it's not the same thing people mean when they say autocomplete. What people mean by reasoning. When most humans say reasoning, we mean something like following rules, tracking constraints, doing multi-step transformations, solving if X then Y puzzles, choosing an answer because it satisfies a goal, not because it's the most common phrase. It's not just words that usually follow other words. It's given a target, can you reliably produce the correct result, even when the correct result is unusual. What autocomplete usually means. Now, autocomplete in everyday life, your phone keyboard, your email subject suggestions, usually means it looks at a small slice of recent text. It predicts the most likely next word or two. It doesn't actively keep a plan. It doesn't check constraints. It doesn't do multi-step computation. It's basically, given the last few words, what do people usually type next? And that's why autocomplete is great at I hope you are doing goes to well. But the reward, apply this new rule, do 3 steps, and output a specific constraint answer. The twist. LLMs also predict next tokens. Here's where the internet arguments get spicy. Yes, many large language models are trained to predict the next token. They generate text 1 token at a time. So someone says on-screen text, that's autocomplete. But that's like saying a chess engine is just choosing the next move. Technically true and totally missing the point. Because what matters is how it chooses the next move. Does it grab the most common move humans play? Or does it compute, evaluate, plan, and follow constraints? So here's the clean way to say it. Keyboard autocomplete is usually a shallow local guess. Large language models are next token predictors that can internalize multi-step patterns and follow global instructions across long contexts. They both predict the next thing, but they are not equivalent in capability or behavior. Now, let's demonstrate. Demo part 1. Goal beats most likely continuation. If something is just autocomplete, it tends to pick the most likely continuation of the sentence. So let's give a sentence where the most likely continuation is obvious, but we instruct the model to do something else. Prompt number 1. Prompt number 1. Fill the blank with a city that makes the sentence false. Output only the city name. Paris is the capital of France, and the capital of France is blank. The most likely continuation is Paris. Autocomplete loves Paris. It's a classic completion, but the instruction says, make it false. A reasoning following answer is something like expected output. Lyon, Marseille, Nice, etc. Goal following overrides the most likely phrase. That's already a crack in the "it's the same as autocomplete" story, because the system is optimizing for an instruction level goal, not just continuation. Demo part 2. A brand new operator, not a memorized phrase. Autocomplete is about familiar continuations. So let's create a tiny math language the model has never seen in exactly this form. Prompt number 2. I define a new operator tensor as follows. For integers a and b, a tensor b equals 2a plus 3b. Compute, double point, 7 tensor 4. Output only the number. Expected output 26. That's not completing a phrase like peanut butter and. That's applying a rule. And you can swap the number. And you can swap the numbers, and it still works. If you want to push it further, prompt number 2b, very flimsy at best. So, define hash by something. A hash b equals a squared 2 minus 2b. Compute 11 hash 6. Output only the number. Expected output 109. Because 11 squared equals 121, a lot of problems. 121 minus 12 equals 109. But the whole thing is rule application related, not equal to phrase completion. Demo part 3. Multi-step state tracking. Autocomplete doesn't hold state in the way we mean for reasoning tasks. So here's a small state machine. Prompt number 3. Game rules. Start at number 3. Commands. Double. Multiply by 2. Flip. Replace n with 10 minus n. Inc. Add 1. Apply commands in order. Double, inc, flip, double, flip. What is the final number? Output only the number. Expected output 4. Breaks again, use 3 goes to double, acting them. 6 goes to inc. 7 goes to flip. 3 goes to double. 6 goes to flip. 4. Well, this is a kind of thing where a shallow autocomplete suggestion has no next common phrase to lean on. It either tracks the state correctly or it fails. Demo part 4. logic with made-up words, no memorized facts. Let's remove world knowledge entirely and test pure structure. Prompt number 4. Determine if the argument is logically valid. Premises. 1. All gleams are blows. 2. Some blows are flames. Conclusion. Therefore, some gleams are flames. Answer with only valid or invalid. Expected output invalid. Because some blows are flames does not guarantee that any of those blows are gleams. If the model gets this right consistently, even with nonsense words, it's not relying on autocomplete style sucked recall. It's using logical form. Demo part 5. Constraint satisfaction. Planning in the output. Autocomplete is typically myopic. It picks a likely next word. Constraint problems require looking ahead. Here's a lightweight one. Prompt number 5. Write exactly 3 sentences. Each sentence must have exactly 5 words. The last words of the sentences must be 1. Stone. 2. Glass. 3. Storm. Thank you for saving me. Output only the 3 sentences. A decent model, we produce something like all roads remember the stone. When you're making a good night trains pass through glass. Brave sailors laugh at storm. Notice what's happening. It has to plan the sentence length and the final word. That's not how keyboard autocomplete operates. So, is it autocomplete or not? Here is the honest version, with no hype and no dunking. If you define autocomplete as predicting the next token, then yes, large language models generate text token by token. But if you define autocomplete the way people usually mean it, local phrase suggestion with multi-step constraint handling, then no, it's not the same. The popular claim, it's just autocomplete, is a category error. It's like calling a jet engine dust blowing air and pretending the turbine design doesn't matter. Same interface, different engine. A quick reality check. Large language model reasoning isn't magic. Now, important. This doesn't mean large language models reason like humans, or that they are always correct. They can make confident mistakes, miss edge cases, fail silently, give answers that sound logical but aren't. So here is a good anti-hype test. Prompt number 6. Count the letters in the word uncharacteristically. Output only the number. Some models get it right, some don't. Entirely, completely to it. And they're gonna the years. And that's your reminder. Always verify when stakes are real. Proof it's not autocomplete. The practical proof. So what's the proof, practically speaking? Not a philosophical proof, a behavioral proof. If a system can reliably follow brand new rules, maintain multi-step state satisfy constraints that override the most likely continuation, solve logic forms with nonsense words, then it's doing something beyond what people mean by autocomplete. It's still predicting tokens, but the process inside the prediction, it's still predicting tokens, but the process inside that prediction can implement reasoning like computation. Next token prediction can contain reasoning. Outro. So, next time someone says large language models are just autocomplete, you can say, yes, they predict the next token. But also, watch this. And then you hit them with the prompt number 1 and prompt number 3. Thank you for watching. Don't forget to like and subscribe, right?